Continuing along, we can also do confidence intervals if we're given two means. When we were given two means and we were doing testing, we did a 2-SAMP T test. Now if we're doing intervals, we'll do a 2-SAMP T int, which is just further down in our list under tests. What it does is it creates a confidence interval for the first mean minus the second mean. The only reason, though, that we're using T's, though, instead of Z's is because we're still going to be looking at problems where sigma is unknown. We're going to have the sample standard deviation S, not sigma. That's why we're using T's, not Z's. So what will the confidence interval ask us for when we run the 2-SAMP? It's a 2-SAMP T int. It's going to ask for almost the same thing that the 2-SAMP T tested. It's going to ask for our sample mean or sample standard deviation and our sample size for the first group of information. And then it's also going to ask for the same information for the second group, a sample mean, a sample standard deviation, and a sample size. It's just instead of asking what kind of tailed test we have, it's going to ask for what's our confidence level. So we'll give it a confidence level. Remember, confidence levels are, let's say if it's 95%, we use. So if we had 95%, we actually use 0.95. And then you'll select calculate, just like before. And it will go ahead and spit out the confidence interval that you get as a result. So let's take a look. So we're going to do the first example that we did for hypothesis testing, but we're going to do it for confidence intervals. So just like the first time we looked at this problem with the 4 cylinders and the 6 cylinders, we're going to use our 4 cylinders as our first group. And then we'll use our 6 cylinders as our second group. And we'll construct, let's see, what do they ask us for? A 90% confidence interval. And notice they tell us which one to use first and second because we're looking at the difference between the 4-cylinder cars and the 6-cylinder cars. So we're going to start with the 4-cylinder cars first. And then we will use our 6-cylinder cars as the second group. Notice it does matter which comes first and second because we are taking the difference. When you're subtracting two things, it does matter what comes first and what comes second. So our group 1 is going to be our 4 cylinders, just like before. So we'll list that as our 4 cylinders. And we know that the sample size is, just like before, 13. The mean of that sample is 137.5. The standard deviation for that sample is 5.8. And then what else did we have? We had our second group, the 6 cylinders, group 2. So 6 cylinders. And the size of that sample was 12. The mean of that sample was, 136.3, and its standard deviation was, 9.7. And we're going to use our confidence level, our C level of 90%. So our C level, when we actually type it in, will be 0.90. So let's see what this is going to look like. Let's see. When we go in our calculator, we'll select again the 2-SAMP T int because again, we have sample standard deviations, we have S's, not sigma. We'll run our 2-SAMP T interval. We will enter in our first group of information, which is everything from the 4 cylinders, which I didn't show all of it, would have been up top here. You would have been listing your X bar 1 first, which would have been 137.5, and your SX1 which would have been the sample standard deviation of 5.8. You can see what comes after that, which is the sample size. Then you'd start listing out your group 2, which is all your information for your 6-cylinder, which we said the mean was 136.3. The standard deviation was 9.7, and the size of the sample was 12. We just said that the confidence level was 0.90 or 90%. And just like before, when we did the testing, we'll leave the pooled off. We'll leave it as no, just like before. And then we'll go ahead and select calculate just like before when we did our testing. And let's see what it spits out. It spits out the confidence interval already completed. So the confidence interval is the first thing that you see after you click calculate. This is your confidence interval. Okay, so the confidence interval begins at negative 4.405 and ends at 6.8051, and it will depend on how they want you to round that, but my math lab will tell you exactly how to round. But that's all there is to it. Now, I've noticed in the homework, sometimes they do something like this. So just to kind of address this, is they'll give you an alpha in part of the problem of, let's say, 0.05, and you'll do a left-tailed test, and then they'll ask you for a confidence interval towards the end, but they won't tell you what your confidence level is. They're actually hinting at it here. So if you ran a, let's say, left-tailed test, means you'd be looking at a picture like this that's left-tailed, and you'd put your alpha and your tail just like you normally do. But you'd say, what does that have to do with my confidence interval? Remember, if we think about confidence intervals as two-sided intervals, well, the only thing that I'd be missing is I've already got my left end. I don't have my right end filled in, which means, remember, it's symmetric. If you had 0.05 on one end, it means you'd have another 0.05 on the other, which means my confidence interval, which would be the inside portion, would be everything else. So what number would go inside for my area inside the middle, the way the confidence interval works? So for my confidence interval, I'd say, well, I need to figure out what that area is for the confidence interval. Well, remember, the entire area underneath this entire curve needs to add up to, if I took all the area from everything, both tails and the center, remember, all this area has to add up to 1. So all of it together has to add up to 1. Well, I've already used up 0.05 on one end and 0.05 on the other. So what does that mean the middle has to be? It has to be 1 minus those two 0.05s, which means I'm actually saying 1 minus 0.10, which is 0.90. That's what I'm going to use as my confidence level. So this gives you an example of what if they gave you an alpha and had you do a hypothesis test and they didn't tell you what the confidence interval is. It is hinted at in the problem because they gave you alpha. You just have to remember that your confidence interval is like having a two-tailed picture. Now let's take a look at another one, just to make sure we've got what's going on here. What if they gave us an alpha of, let's see, 0.05 again, but we had a two-tailed test we already did? Well, then let's draw our picture. If we have already done a two-tailed, we'd be looking at something like this, with our alpha being the area in both tails already. So the area in both these tails together would already be 0.05. So then when I look for my confidence interval, which is two-sided as well, I'd be just looking for whatever's on the inside. Well, I've already got both ends this time. So my confidence interval that's in the center here would be just 1 minus what I had in my two tails, which we already have as 0.05, which would leave me with just 0.95. So that would be telling me I'm just going to be doing a 95% confidence interval. And again, it works out nicely because it was already two-tailed. So what this tells me is if I had done a hypothesis test with a two-tailed with an alpha of 0.05, even though they don't give us a confidence interval directly, we can find it. It would be a 95% confidence interval they'd be inadvertently asking for.